this video, we are going to attempt past paper questions related to solutions and mixtures. We are going to attempt structured questions for AP chemistry. In the first question, what they are saying to us, that there are three dyes which are present on a chromatogram paper, and you can see one thing, we have three components A, B and C. So now what happens, they have given us that a student prepares the chromatography chamber shown above on the left by putting a drop of each dye at the indicated position on the chromatography paper, which is a polar material. Remember, it is a polar material, and standing the paper in a non-polar solvent. So now they are saying which dye ABC is the least polar. So first of all, they are non-polar solvent. Non-polar solvent is present there, and now we have to see which dye is going to be least polar. So least polar dye is going to be C. Why C? Because non-polar dyes, they are more strongly attracted to non-polar solvent. Okay, so now we can see one thing, that non-polar dye will be more strongly attracted to the non-polar solvent. So we can see one thing, that the dye which is going to be most non-polar or most least polar, that would travel the more further. Okay, so the dye which is going to be least polar dye, that is going to have more attraction with solvent and would travel more further and would travel more further. So which dye has traveled most further? That is going to be dye C, which is going to be least polar. Why it is least polar? Because it travel most further. In the next question, which dye is present in the unknown sample? So there is an other unknown sample as well, which contains again the non-polar solvent, and now they are saying to us that which dye is present in unknown sample. So the dye which is going to travel the same distance as the unknown sample or closer to it, that is going to be the dye. So we can see that dye A is the one which has traveled closer to the unknown sample. So we are going to say that it is going to be dye A. Why dye A? Because unknown sample moves to a position that is midway between the origin and solvent front, and so does dye A, Next question is, a student prepares 250 milliliter solution of 0.250 molarity NaCl by diluting a more concentrated solution. Describe what molarity represents. So, molarity is basically the concentration of solution, that is a concentration of solution, and that is expressed in mole per mole of solute divided by liter of solution In this question, calculate the volume of 1 molar NaCl stock solution required to prepare 250 milliliter of 0.250 molar solution. Now, we have to use the formula M1V1 is equal to M2V2. M1, this is M1, that is for the stock solution. And then we have M2, which is going to be 0.250, and then we have V2, which is 250 milliliter, and we have to convert it into liter, that is divided by 1000, 0.25 liter. And V1, we have to find out V1. So M1V1 is equal to M2V2. V1 is equal to M2V2 divided by M1, and M2 is what? That is 0.250. V2 is what? 0.25 divided by M1, which is going to be 1. So answer comes out to be 0.0625 liter, and we have to convert it into milliliter by multiplying by 1000. So answer comes out to be 62.5 milliliter. So next question says, describe how to accurately prepare 250 milliliter of 0.250 molar NaCl solution in a laboratory. So we have to measure this much volume of liquid. So we have to measure 62.5 milliliter of 1.00 molar NaCl solution, and we have to dilute it to 250 milliliter with distilled water in a volumetric flask. What happens to the molarity and the number of moles of solute when a solution is diluted? So what happens? The mole of solute, they remain constant. But if we are talking about the molarity is basically equal to mole per unit volume. So you can see by increasing the volume, what happens to molarity? As molarity and volume, they are inversely proportional, so it would decrease the molarity, okay, but increasing the total solution volume will decrease the molarity. So they are saying seawater contains dissolved salts like NaCl, MgCl2, CaCl2. These ions affect properties such as conductivity and salinity, which are important in environmental and marine chemistry. Explain in terms of interaction at the molecular level why ionic compounds readily dissolves in water. So guys, you know one thing I have told you before as well, like these ionic compounds like Na positive, they are going to develop the force of attraction with oxygen in water, because oxygen is having partial negative charge and it is having partial positive charge. So you can see that is basically ion dipole attraction. Ion dipole attraction. So we can say one thing here, that water is polar, and if water is polar and interacts with ions, and it interacts with ions, and what is going to be that force? That force is ion dipole forces. Explain how these interaction allows seawater to conduct electricity because of the presence of free moving ions. Because of the presence of free moving ions in solution, they can conduct electricity. Calculate the total concentration of these ions. So for NaCl, a seawater sample contains the following concentration: 0.550 molar NaCl, 0.250 molar MgCl2, and 0.1 molar CaCl2. We have to find out the total concentrations of ions in the solution. So for that, NaCl contains two ions. As you know, it contains Na positive and chloride ion. So it contains two ions, so its molarity will be 0.550 times 2, that comes out to be 1.10 molar. And for MgCl2, it contains Mg plus 2 and 2 chloride ions, so total ions becomes 3. So that is going to be 0.250 times by 3, and that becomes 0.750 molar. Then for calcium chloride, it contains calcium plus 2 ions and 2 chloride ions. So it becomes 0.1 times 3, that is going to be 0.300 molar. So total concentration of ions would become 1.10 plus 0.750 plus 0.300, so that would become 2.15 molar. Now explain why a 1 molar solution of MgCl2 conducts electricity better than 1 molar solution of NaCl. So we can see MgCl2 that contains 3 ions, as it contains Mg plus 2 and 2 chloride ions, and NaCl contains only 2 ions because it contains only Na plus and Cl minus. So we can say that MgCl2 produce more ions per mole. So therefore, higher ion charge and number increases, increases conductivity. The diagram below shows simple distillation steps setup used to separate pure water uh, from. So you can see this is a like the method. So label the component where salt remains. So salt remains at this part. Why? Because what happens, this is a salt solution, and when it is heated, what happens, water vapors, they tends to move upward, where they are going to pass through condenser. And what happens in condenser, cold water enters from this part and warm water leaves from this part, warm water. Then what happens, pure water collects here, pure water collects here. Then explain why this method successfully separates water from dissolved salts. So what will happen here, that the water evaporates, the water evaporates, and what will happen, then it is going to be like condenses and is collected, while salt do not evaporate, do not evaporate. Why don't evaporate? Because they have high boiling point, due to their high boiling point. For next question, assuming this residue consists of mixture of NaCl, MgCl2 and calcium chloride in the same mole ratio as in part C, calculate the percentage by mass of NaCl in the total dissolved salt. So we are given with the moles of NaCl. NaCl is going to be 0.550 mole, and by multiplying mole with molar mass, and mr of NaCl is going to be how much, that is going to be 58.44 gram per mole. And if we are going to find out its mass is going to be mole time molar mass. Mole is 0.550 time with molar mass, that is 58.44, and that comes out to be 32.14 gram. For MgCl2, that is going to be 0.250, and mr of MgCl2 is how much, that is going to be 95.21 gram per mole, and mass is equal to 0.250 times 20 times 95.21, and that is going to be 23.80 gram. Similarly, for the last one is going to be calcium chloride. Calcium chloride has the moles which has been given to us is 0.1, and mr of calcium chloride is going to be how much, that is going to be 110.98, and for mass I'm going to multiply them both, 0.1 multiplied by 110.98, and that comes out to be 11.10. Then when we have to calculate for like first we are going to calculate the total mass of the mixture, and that is going to be 32.14 plus 23.80 plus 11.10, and that comes out to be 67.06 0.04, 67.04 gram. To find out the percentage by mass of NaCl, percentage mass of NaCl, what we are going to do, we are going to put the mass of NaCl at top 32.14 and at bottom the total mass, that is 67.04 times by 100, and that comes out to be how much? That comes out to be, just let me calculate it, that comes out to be 47.9%. Now they are saying if we have total residue which is 4.98, then what is going to be the mass of NaCl? So 47.9 divided by 100, as it was a percentage, times by 4.92, and the answer that comes out to be is 2.36 gram of NaCl. A forensic scientist is analyzing a mixture of dyes using paper chromatography to determine if a suspect pen matches ink found at a crime scene. So explain why chromatography is effective for separating the component of solution. So the reason is that it separates substances. It separate substances based on their based on their different solubilities in mobile phase, in the mobile phase, and their interaction with the and their interaction with the stationary phase. Stationary phase is paper. Stationary phase is paper. So describe the function of the mobile phase and the stationary phase in the paper chromatography. The mobile phase is the solvent. The mobile phase is the solvent that carries the the dissolved components of the dissolved components of the mixture up the chromatography paper, up the chromatography paper. The scientists measured the RF value of two dyes in an ink sample recording 0.35 and 0.72. Remember, if it's 0.35, then that means it moves less, and that indicate it has stronger intermolecular force with the paper. So the dye with RF is equal to 0.35 moves less, and indicating stronger intermolecular force with the paper. In the next part, they are saying predict how changing the mobile phase to a more polar solvent would affect the RF value of both dyes. The RF value of more polar dye will increase. If the mobile phase becomes more polar, if the mobile phase becomes more polar, then what is going to happen? The RF value of more polar dye, the RF value of more polar dye, and more polar dye is here going to be RF, which has a value of 0.72, that will increase. It would become more polar. A student is investigating the miscibility of three liquids, ethanol, hexane, and water. Ethanol is having hydrogen bonding, while water is also having hydrogen bonding, because they both are polar. They both are polar. They both are polar. While hexane is non-polar. That is non-polar. What is hexane? Hexane is um, C6H, that is 14. It contains carbon and hydrogen, which makes it non-polar. So they are saying predict whether ethanol and hexane are miscible in each other and justify your answer based on intermolecular forces. So they both are not miscible. Not miscible. The reason is that because ethanol molecules are polar. They are polar, interacting through hydrogen bonding, interacting through hydrogen bonding and dipole-dipole force and dipole-dipole forces, while hexane molecules are non-polar. While hexane molecules are non-polar and which interacting through London dispersion forces. London dispersion forces. Explain how hydrogen bonding in water molecules influence the solubility of other substance in water. So that hydrogen bonding in water that allows water to dissolve polar substances and those capable of hydrogen bonding and those capable of hydrogen bonding, while non-polar substances do not dissolve well. Do not dissolve well. A student adds acetone to both water and hexane. Predict which liquid acetone will mix better with and justify your answer in terms of relative intermolecular force strength. Acetone will mix better with water. Acetone will mix better with water. And what is going to be the reason? The reason is that because it is polar, because it is also polar, and if it is polar and interacts with water and interacts with water with water via dipole forces, dipole dipole forces. In contrast, if you see hexane, okay, hexane I have told you is C6H14. So in contrast, hexane is non-polar. Hexane is non-polar and has only London dispersion forces. London dispersion forces, which are much weaker, than dipole forces. Then dipole forces. So in this question, a student in a chemistry lab is preparing a standardized solution of aluminum sulfate for an acid-base titration experiment. The student accurately weighs out 8.56 gram of aluminum sulfate and dissolve it in 250 milliliter of distilled water. The student then dilutes 50 milliliter of this solution to 200 milliliter with additional distilled water. He is saying calculate the moles of sulfate ion present in the dilute solution. So for that purpose, first we need to find out the moles of aluminum sulfate, and for that first we need the MR of aluminum sulfate, and that comes out to be how much? That is going to be 342.14 gram per mole. And then we have to calculate the mole of Al2SO4 whole thrice, that is mass over molar mass. Mass is 8.56 and molar mass is 342.14, and then that comes out to be 0.02502 moles. And then moles of Al2SO4 whole thrice in 50 milliliter of solution, and that comes out to be 0.02502 times by 50 divided by 250, and that comes out to be 0.005004 moles. In the next question they are saying and you know one thing, right now we also need to calculate, I think we also need to calculate the moles of sulfate ion, and we know one thing, Al2SO4 whole thrice, that contains 2 moles of aluminium plus 3 moles of sulfate ions. So if it contains 3 moles of sulfate ions, then what we need to do, we are going to do 3 times 0. No, here 3 times 0.005004 moles, and that basically I think we have done this part. Yes, we just need to multiply. First of all, no, one thing that we have done wrong here, that thing is going to be Yes, we have to multiply this one with 3 times this value, and that comes out to be times 50 by 250, and that comes out to be 0.01501 moles. Why the total number of sulfate ions remains the same after dilution even though conductivity decreases? Because what happens, no ions are removed, no ions are removed are removed then what happens, but the electrical conductivity decreases, but the electrical conductivity decreases, and the reason is that because there are less ions per unit volume, because there are less ions per unit volume. They are saying a second student prepares a diluted Na2SO4 solution at the same sulfate ion concentration as aluminium sulfate solution. Compare the electrical conductivity of sodium sulfate solution to aluminium sulfate solution. So we can see one thing here, that sodium sulfate solution, what it tends to do, sodium sulfate solution has higher electrical conductivity. What is the reason? The reason is that because Na2SO4 dissociates into more free moving ions, per formula. And aluminium ions interact more strongly. Aluminium ions interact more strongly with sulfate, reducing mobility.